but I guess the way you would solve it would be as follows, right? So to solve it using the equation, which some of you may prefer, we would do the following. We know that when m equals 0, so let me rewrite that equation first. G equals f minus m fs, and G is between these two values. When m equals 0, what we have is that G equals the absolute value of 0.833 minus 0, right? So that's 0.833, right? So this is, saying that this value of f aliases to itself. It doesn't alias at all, in other words. So that's okay. That's something that we knew already. When m equals 1, we now know the alias frequency. So in the top equation, what we would write is that 0.833, which is G, is equal to F1 minus 1 times 2 megahertz, right? 1 times 2. And then we would have to solve for this. So how do we do that? This is saying that f minus 2 is equal to plus or minus 0.833, right? Because so there's two possibilities here. Because the absolute value is equal to 0.833, that means it could either be positive 0.833 or negative 0.833. And then f1 equals, therefore, 2 plus or minus 0.833. So that equals 1.167 or 2.833. Right? So we get two answers out of that, which are this frequency and this frequency over here. To get the third frequency, we would have to do the same thing with m equals 2. Right? But I find, just going through this formula, really, it doesn't shed any light onto what's actually going on. Whereas if you just memorize this picture without all the numbers on it, just the general picture, or not memorize it, but write it on your cheat sheet or your A sheet, then you should be good for this kind of question if you understand what that all means. Okay, so there were some follow-up questions on this, which we can talk about. So we talked about E, and we got our 3 answers. I won't write them down again. And these follow-up questions were to do with quantization, which was another topic. So let's continue with this question and switch gears to quantization. Okay, so this question once again refers to this picture. If you've got your package, you can see them. The question says, the oscilloscope quantizes the signal with fixed resolution, assumed to be 12 bits. The vertical range is said to be able to measure minus 10 volts to plus 10 volts. What will be the maximum quantization error due to rounding? And the hint is the maximum quantization error occurs when the voltage is midway between the two quantization levels. So we'll see that. And then the other sentence is not really relevant to us answering the question, but it's just interesting information. Okay, I'm going to have to, there's no space on there, so I'm going to have to, okay, so when you have a quantizer, you're either given the number of levels, and if you're not given the number of levels, you're given the number of bits in the quantizer. So in this case, there are 12 bits, right, in quantization. Can you see that? No. Okay. So how many levels does the quantizer have if you know that it has 12 bits? The question is the same, actually, as asking how many numbers can you represent with 12 bits? Because I'm asking how many levels can you represent with 12 bits? So it's exactly the same question. And that means that the answer is 2 to the power 12, right? A rather large number. So, I guess 12 bits of quantization creates 2 to the 12 levels. The question also says that we're able to measure between minus 10 and plus 10 volts. So let's draw a vertical axis that goes from minus 10 volts to plus 10 volts. Okay? And the very top quantization level is at plus 10 volts, and the very lowest quantization level is at minus 10 volts. And between those two, there are a large number of other levels. You know, in total, there are 2 to the 12 levels. Okay, so maybe I can draw them like this, and like this, looking at the bottom, and then dot, 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 because there's an awful lot of them. Okay, so the question was, what is the maximum quantization error? And the hint was, the maximum quantization error happens when the signal falls directly between two levels, right? So for example, this pair right here, if we had our signal right in between, that's when we maximize the quantization error, because if it were a little bit lower than that dot, you know, that dot would quantize to the level below. And if it was above that dot, it would quantize to the level above. But when it's right in the middle, no matter which way it quantizes, the error is equal, right? You cannot make the error more, because if you went higher, you'd make the error less, because you'd get closer to the top level. If you went down, you'd make the error less, because you'd get to the lower level, right? So the answer, the maximum quantization error, is the distance between that dot and the lower level, or the upper level, you know. It's that distance. It's half of the distance. So maximum quantization error is equal to 1/2 times the, let me call it the quantization interval. Right, the distance between quantization levels. So we need to figure that out. What is the distance between the quantization levels? How can we calculate it based on this picture? Someone else, I guess. Yes.
So it would be just the 20, the total voltage difference,
yeah,
and
the range
divided by 2 to the 12.
So good suggestion. So we know that each of these, you know, I haven't drawn them quite nicely, but each of these quantization intervals is supposed to be equal. So the distance between any two is going to be the entire range, 20 volts. Right, that thing is going to be 20 volts divided by the number of intervals. Right, I write down number of intervals there because it turns out that the number of intervals is not equal to 2 to the 12, which is what was suggested. It's equal to 2 to the 12 minus 1. Okay, so that is 20 volts divided by 2 to the 12 minus 1. So, so if I had two levels, right, one up here and one down here, how many intervals do I have? One less than the number of levels, right? So that extends to 2 to the 12 as well. I hope that argument is kind of clear. You have one less interval than levels, because you've got to have one level at the top and one level at the bottom. Okay, so this, I guess, it needed a calculator to figure this out.
You won't get a calculator, right?
Yeah, so you could not answer this question without a calculator. I mean, you could, but yeah, we won't. So, okay, putting all of this together, the max quantization error. Is equal to 1/2 times 20 divided by 2 to the 12 minus 1, which is equal to 0.0024 volts. Okay, you can end this question. Now, if you had left off that 1, you would probably get very close to the same answer. So it wouldn't have been a catastrophic mistake because we have so many levels. That 2 to the 12 is approximately equal to 2 to the 12 minus 1. But if you say you only had 8 levels, then you have 7 intervals, and 8 and 7 are, are kind of different. And they're more different. They're like 12% different, right?